This video is on the objective calculate the test statistic for testing the difference between two means. Alright, and this is a z-score, a z-value, because the population standard deviations are known, right? Sigma 1 and sigma 2. Right, the standard deviations for these two independent populations are known. So you're eventually going to be dealing with a normal distribution instead of a student's t-distribution with so many degrees of freedom. All right. So again, if you want to see how they're doing things, how they're instructing you, click on more instruction. Look at their videos, their notes, their examples. Hopefully those help you out. All right. So here we have Ariana Estefan manages Salmon Falls Park, which has two flagship roller coasters, the Flyer and the Destroyer. When Ariana walks around the park during hours of operation, she notices that there are fewer people waiting in line for the Flyer than for the Destroyer. Since both roller coasters have similar capacities and similar run times, both roller coasters should have about the same number of riders. Based on the anecdotal evidence, Ariana claims that the population mean number of riders per hour on the Flyer is less than the population mean number of riders per hour on the Destroyer. Ariana reviews data collected in the past and assumes that the population standard deviation is 48.29 riders for the Flyer and 51.86 for the Destroyer. Ariana randomly selects hours during which the attendant of each ride counts the number of riders. The sampling occurs over the course of several weeks. The results are provided in the table shown below. Assuming the conditions needed for the hypothesis test have been met, right, because the sample sizes are sufficiently large, the population standard deviations are known, we're going to assume that these samples are independent, right? So results from one sample have no effect on the results from the other. So and the samples were taken randomly, right? I mentioned the random sampling earlier. So all we're assuming here all the conditions are met needed for the hypothesis tests that have been met. All right. What is the z test statistic for this hypothesis test, rounded to 2 decimal places? All right. So let me go to some paper here and I'll write some of this stuff out. Now, again, you have two independent populations, and you got two samples, right? One from each population. There are the riders of the Flyer roller coaster, and it says here that the average number of riders per hour, right, in those randomly selected hours she took is 109.62, and she took a sample of 54 hours, right, 54 randomly selected hours, and tried to figure how many riders per hour, on average for that sample. And then for the Destroyer, right, the other roller coaster, for the randomly selected hours, the average number of riders per hour for the Destroyer was, for this sample was 124.71. And the second sample size here is 51 hours that were randomly selected, pardon me. Now what we're doing is we're testing about the difference of means here, right? The difference, x1 bar minus x2 bar. Right. And for our samples here, right, that would be 109.62 minus 124.71. Right? And we'll calculate that in a second and use it in our calculation of the test statistic. I am so sorry about my snifflies. Alright. Now, what the distribution you'll end up looking at here, and this is with, sigma 1 and sigma 2 known. Right? She said on previous data the population standard deviation for the number of riders per hour on the flyer was 48.29, and the population standard deviation for that average number of riders per hour on the destroyer was 51.86. Okay. And since these are known, right, these are known values, we're going to be using a z distribution, standard normal, or just a normal distribution. The distribution of your x1 bar minus x2 bars will be a normal distribution, and the mean value is going to be mu1 minus mu2, and the value of mu1 minus mu2, this is going to be assumed to be 0 in the null hypothesis. Right? Now, I'm not setting up hypotheses here, but in the null hypothesis, right, in H0, mu1 minus mu2 will be assumed to be equal to 0. These are going to be, so mu1 and mu2, the two population means, the average number of people that go on the flyer per hour and the average number of people that go on the destroyer per hour, we're going to assume that they're equal in the null hypothesis. All right, and then the standard deviation of this distribution of the difference in sample means here, I put this up in a previous video, is the square root of sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. All right, and we have all this information. All right. And then your test statistic will just be, hey, look at this distribution of the difference between sample means. We're going to take a look at our difference and find the z-score for our difference. So we take our sample means and subtract them. So x1 bar minus x2 bar. And then subtract it from the mean of this distribution, which is going to be 0. We're going to assume it's 0 and then decide whether or not we like that. Are we going to reject that or not later? So you can put minus 0 if you want, but there's no need for that. And then divided by the standard deviation of the distribution, which is this crazy square root here, right? The square root of sigma 1 squared over n1 plus sigma 2 squared over n2. Alright, so I'm going to put in the numbers involved here. So again, your numerator, 109.62 minus 124.71. There's the difference between our sample means. And then how many standard deviations is that away from 0, right, away from the middle of this normal distribution here? I'd be dividing by the square root of sigma 1 squared, right, so 48.29 squared divided by n1, so n1 was 54, plus, and then sigma 2 squared, right, 51.86 squared divided by n2 divided by 51. And again, make sure when you're punching this in that all of that is underneath the square root symbol. So I'm going to pull up a calculator and we'll do this. Alright, so in the numerator I'm going to put in parentheses because there are multiple terms. 109.62 minus 124.71. Okay, so there's the difference in our sample means divided by, and then the standard deviation of the distribution of the difference in sample means. That's square root. And again, if you have an older one, you might have to put parentheses around all this, but make sure all of this stuff is underneath this square root symbol. So we have 48.29 squared divided by 54 plus 51.86 squared divided by 51. Again, notice how the square root bar just kept getting larger. This is all underneath the square root symbol. So rounding this to 2 decimal places like they're asking me, rounds to negative 1.54, right? And it should be negative because, you know, this difference in sample means is a negative number, right? And that's going to be less than 0, which is our assumed population difference in the population means mu1. We're going to be assuming from the null hypothesis that mu1 minus mu2 equals 0. Yeah, so our test statistic is negative 1.54. You know, the difference in our sample means is, you know, 1.54 standard deviations below the assumed middle. You know, if the population means were assumed to be equal. And then we would determine, is this far enough away, or is this z-score in a rejection region if you're doing the critical value method, or you'd find the p-value of this if you're doing the p-value method, and then compare the p-value to the significance level alpha, make your decision about the null hypothesis, do you reject it or not, and then you write a conclusion. All right, but here we're just given the z-score, so entering here negative 1.54. Wonderful. Okay, and again, they go through the same calculation I just showed you. And this is going to be your test statistic for this whole section. All right, this whole section of homework. All right. So again, hopefully watching me do that helps you out, you know, looking at their more instruction perhaps, or reading their answer explanations when they come up. Hopefully all this stuff helps you when you're working on this material on your own. And thanks for watching.